I welcome you to the lecture series on DBMS. And as you know, this is the revision module for the relational algebra section. And it has been just started from the previous lecture. And this is the second lecture in this revision module series. Okay, so today's topic is selection of columns and several others. We'll go through them. So, suppose I want to select columns or attributes, then which operator I will use? Projection. Okay, and this is the projection symbol. Means now you are going to select the columns. In the previous lecture you have seen that with the select operator we are focusing on the tuples. Now attributes. So say this is the same table ABC. Now I am applying this projection operators on AC. Okay, so what would happen then? Out of this ABC, only A and C will be selected and the duplicates are removed. So apply this to this table, means select columns R, A, C from R. Now this is the result, AC coming. Now you will see that alpha 1, beta 1, beta 2. So alpha 1 is a duplicate, so has been removed. Then overall the result as a table will get this one. AC, alpha 1, beta 1, beta 2. Okay. So projection operation clear. Now example in details. I'm considering again the instructor table. And question is that return those instructors whose salaries are more than 85,000. Now for that you need to write the equation, and the equation will be this one. Okay. So first of all, I want to select those values where salary is greater than 85,000, isn't it? So that's why as I am targeting the tuples, I am using the select operator, and salary greater than equal to 85,000 from who is table? Instructor. So overall, I will get this one. As you have seen that salaries are all are greater than 85,000. Now I want only the instructor say ID and salary, not this the name and department. What operators I will apply now? As their columns, I will apply the project operator. The equation will be phi ID salary from this instructor. So overall, if I have been facing a question like that, find the ID and salary for those instructors who have salary greater than 85,000. The equation will be what? First, as I have mentioned, I have selected the tuples where salary is greater than 85,000, and that is this one. Now, from there, I am just focusing on the ID and salary portion. So, by ID and salary. So, overall, this is the one where I am targeting. Now, from there, suppose some one more instruction being given to it, then I can frame the equation in that way, and the ultimate filtered output will be coming. So got it? So this question is very important. Find the ID and salary for those instructors who have salary greater than 85,000, and this is the particular equation for that. I hope you have got it. So take a screenshot and try to analyze it further. Okay. Now coming to next, joining two relations. If we want to join two tables, two relations, we will first apply Cartesian product. Say R, A, B, alpha 1, beta 2. This is a table R, this is a relation R, and this CD, this is S. Now R cross S. What will be the result? See, in this case, this alpha 1 will be combined with every possible tuples combinations, means combined through every possible combination, means alpha 1 will be combined with each of the tuples. So alpha 1 alpha 10a, alpha 1 beta 10a, like that. Then beta 2 alpha 10a, beta 2 beta 10a, beta 2 beta 20b, beta 2 gamma 10b. So overall this is the result. So ultimately all the possible combination will be coming out as a result of R cross S. This is the cross product. So overall, if instructor has 12 and department has 7 tuples, then this instructor cross department will have 12 cross 7, 84 tuples. So number will be multiplied. That is our Cartesian product. Now coming to natural join. Now as you are now aware with the Cartesian product, now you can apply natural join. What is natural join? Let R and S be the relations on schemas R and capital S respectively. As I have repeated many times that this capital R or capital S, this means capital notations are used for denoting the schemas of the respective relations. Okay. Now then the natural join of relations R and S is a relation or the schema R union S, and it can be obtained as follows. Consider each pair of tuples TR from R, TS from S. If TR and TS have the same value on each of the attributes in R intersection S, add a tuple T to the result. But you should note that T has the same value as TR on R and T has the same value as TS on S. So these 2 points are very much important, okay, by which we are calculating the natural join. Just take an example. Say R, this R schema is containing A, B, C, D, and S schema is containing E, B, D. The resultant schema will be what? A, B, C, D. Of course, you know that A, B, C, and D, E. Then R natural join. This is the symbol for natural join. You should note it. It will be defined as. So first of all, I am selecting the values from R cross S, that is cross product, and what values, what tuples values. That sigma operator, that select operator, where R dot B is equal to S dot B, intersection R dot D is equal to S dot D. They are simultaneously happening. Now, from those tuples values, I'm going to consider our attribute values, that is pi operator or project operator being used. So R dot A, R dot B, R dot C, R dot D, and S dot E. Well, so as a result, we'll get the R natural join S. Clear? Now, as an example, natural join example, I'm considering this ABCD table and BDE table. You just take a screenshot, it will help you to analyze. So A, B, C, D, and BDE. So you see that B and D are to the common attributes. Okay, so as a natural join, we'll have ABCD. So ABC coming from ABCD, A, B, C, and D coming from R, and E from S, suppose. Okay, so we'll take the common values alpha 1, alpha A, alpha, because you see that 1, 1, and the D, A, and A, that is the same value. Similarly, other same values you need to analyze, and as a whole, you will find a result. So alpha 1, alpha A, alpha. So 1 and A we are focusing on. Then similarly, alpha 1, alpha A, gamma, because with this alpha 1, alpha A, that A values with gamma coming with respect to B value 1, isn't it? So similarly, alpha 1 gamma, A gamma alpha, and alpha 1 gamma, A gamma, alpha gamma to beta B gamma. So it's very easy. You just analyze this. If you find difficulty, you can comment me again, then I'll go through it. And you do note that this is a revision tuple. I already have a lecture on the natural join itself. Go through it if you have not already. Okay. So that's the result coming out. So I hope you have got it how I am calculating it. So similarly, you can go through the natural join of the instructor table. This is the instructor table and department table. And you can analyze your result with this one, because as a result, we'll get this as the instructor natural join department. Okay. So you can show the output only the attributes ID and building. For that, you just need to take what? Projection operator on them. Okay. So I hope today's lecture covers the maximum of the operators possible. Now you go through the lectures again, once again, analyze those operators. Okay. And that will be sufficient for you. So meet you in the next lecture. And don't forget to uh, comment if anything find difficulty for you. Okay, meet you in the next lecture. Till then, take care. Bye bye.